And let's. Oh, by the way, you can use a calculator on this one. Do you have a calculator by chance? Does everyone have a calculator? Now grab a calculator, guys. Let me grab my calculator too. I already cleared it. Minimize. All right. Here we go. UH test 2 integration. This is from one of y'all. They made an attempt. It says, use the graph below to answer the following question. And it says the area of the region bounded between the graph of f and the x-axis from -1 to x equals 0. So all this right here. That is 2. And then it's from 0 to 2 is 4. So all this right here is 4. And from 2 to 4 is 36. From 2 to 4, all this is 36. Yes, if it's below the x-axis, it says evaluate the integral from -1 to 4. So integral from -1 to 4 of f of x dx. If your professor tells you, like, what is this called? This is called signed area, guys. So I'm going to write the word signed area because it's below the x-axis. It's -2 equals -2. This one, the signed area is just 4. And this one, because it's below the x-axis, signed area is -36. Does that make sense to you guys? All right, so I'm just going to go -2 because it wants to go from -1 all the way to 4. -2 plus 4 minus 36. So let's see, -38 plus 4, that's going to be a -34. And there it is. That's the answer. How are we feeling, guys? Okay, let's go to number 2. And then stop me if something doesn't make any sense. It says calculate the integral 4x sine x squared plus 4 tan x cosine x cosecant x. All right, they're just being so tricky. Tan x is the same thing as sine x over cosine x times cosine x times, and then cosecant x is the same thing as 1 over sine x. And yep, everything cancels out. Cosines cancel out, sines cancel out. So I just have the antiderivative of 4. So the antiderivative of 4 is, 4x. So delete letter B, delete letter D, and delete, okay, that's it. So it's between A, C, and E. So now we got to worry about this guy. What's the antiderivative of that guy? So if you see it, you can just do the antiderivative right off the bat. But if you don't see it, then use substitution. Antiderivative of 4x sine of x squared dx. Child, what about the 4? We already know the antiderivative of 4 is 4x. You know what I mean? So I'm just doing this. So check it out. I'm going to go u equals x squared. du equals 2x dx. Have I confused anyone? So I see that 4, and I'm going to write a 2 there and a 2 on the outside. Because 2 times 2 is 4, right? So here we go. 2 integral of, and I'm just substituting, guys. 2x dx is du, but put that at the end. So sine of u du. So what's the antiderivative? 2. What's the antiderivative of sine? Negative cosine of u plus c. And then there it is. That negative, just put it in the very front. -2. And then since we don't have any limits, it's not about you. It's about your, we're going to go back to our x here. -2 cosine of x squared plus c. So there it is. Did I hear a chicken?
Yeah, that's it.
Was it someone laughing? I thought I heard a chicken. I've been to too many farms. How do we feel about this, guys? Okay. Let's go to this one. This one looks kind of funny to me. So again, I would do u substitution again. Child, how do you know what to do? Well, I see a 2x squared here, and I see a x in the denominator. So I'm not gonna take it out because we can't take it out, but I'm gonna make that the u. You know what I mean? So watch, ln 2x squared over x dx. I'm gonna go u equals 2x squared, du equals 4x dx. That's not gonna work. Do you see how that's not gonna work, guys? So I'm gonna be forced. I'm forced to make u equals ln of 2x squared. Why are you forced? Because I'm gonna have this. Don't worry, you're gonna get a linear 1 over 2x squared times chain rule. What's the root of a 2x squared? 4x, put the dx in there. I'm just doing algebra, guys. 4x over 2x squared dx. And I'll slow down. So let me slow down. What's 4 divided by 2? Okay. And then I have an x on the top and 2 x's in the bottom. How many can I cancel? Yep. So here we go. That's what I have. 2 over x dx. So what do I need? So let me change my color. What do I need in my integrand here? A 2 on the numerator. So then I put a 1/2 on the outside. And here we go. 1/2 integral, the 2 ln 2x squared dx. Well, with the x on the bottom is going to be, so this is just going to be u du. Because the ln of 2x squared is u, right? All right, here we go. 1/2. Leave some room. Dot. Antiderivative of u is u squared over 2 plus c. What's 2 times 2? 1/4 ln parenthesis 2x squared, close it. Put a parenthesis around the whole thing of that plus c. And we look for that answer.
So it's 2x squared?
It's 2 ln 2x squared, yes. Bam. Right, hold on, Miss Cruz texted something. Is the ice cream's not there? I followed the directions. It's at 10 a.m.
You know, if anything, they would have called people, though, because it's in every different advisory. I mean, class.
Maybe they meant it during advisory, but then you guys have something during advisory also. Your graduation pictures or something. Registration?
Oh, my goodness.
Registration for graduation pictures. Something like that.
Oh, is the guy kind of going down Johnston's?
I think so. All right, guys. On this question, I'm going to let you guys use your calculator. That's fine to make it fast. There is a hack. But hold on, before you do anything, it says find the area of the region bounded by the curves and the x-axis between -4 and 1. Remember that area, unless it says the word signs, area is always positive. So here's how 1 minus x squared looks like. Here's 1, and it looks like this. That's -1, that's 1. And I guess I'll keep stretching it until I get to like 4. I'm going to say 4 is right here, or -4. And here's 1. So I need to find this area here first. And whatever that area is, I know it's going to be negative, unless you do one integral like 0 minus 1 minus x squared, unless you do that. So I know that's going to be negative, and I'm going to turn that into a positive. So I'm going to go integral from -4 to -1 of 1 minus x squared dx. And I'm going to find what that is. So take your calculator. And I'm going to go math. Which one is it? You can if you want. Numeric integration. 9, -4, all the way to -1. Remember, I'm doing it in pieces. Of 1 minus x squared. Was it 1 minus x squared? It was, right? 1 minus x squared dx. Now, whatever you get, you're going to turn into a positive. So I got -18. So I'm going to write for now, -18. I'm going to put in here for good notes. Turn positive. And now I'm going to find this area here. Oh, because it says find the area. And area is never negative. And now I'm going to go from -1 to 1. You can, if you want, go -1 to 0 and then multiply it by 2 if you think that's easier. But if we have a calculator, just go -1 to 1. So I'm going to go here. And you should get a positive number. If you don't get a positive number, that's a hint that something's off. -1 to 1. And there it is, 1.33333. Turn that into a fraction. Math, frac, enter. 4/3. What's up?
So I know that the numerator will be it's like the top line minus like the lower line, right?
Yeah, you can do that. 0 minus 1 minus x squared, and it'll turn into a positive.
So why is like if you see how the curve is like above the x-axis?
Uh-huh.
Under and out. Wouldn't that mean that for -4 to -1, should that be like the equation itself be negative? Because it's below? I don't know how to explain it.
I think what you're trying to tell me is, how do I force, when you do upper minus lower, that's why I told you that yes, you can do that. If you set the x-axis is y equals 0, then you can go 0 minus 1 minus x squared, integral from negative 4 to negative 1 dx, and this will give you a positive 18. I think that's what you're trying to do, right? So this, if you do this, 0 minus this, that will give you a positive 18. You want to try it? Just so you can see? Oh, I just like, signed area. I mean, I could have. There is a hack, but I don't know if we're ready for the hack. What's 18 plus 4/3? 58 over 3. Do you guys want to see the hack? But I don't want you guys to be robots. 58 over 3. Okay, there is a hack. What is a hack? If I put absolute value of 1 minus x squared, that graph will look like this.
So then it gives us the total area.
Yep. If I do that, you see how if I do absolute value, I'm putting all this in a circle. See how everything's above the x-axis? So you can, but guys, don't be a robot. You can negative 4 to 1 of absolute value of 1 minus x squared dx, and that should give you that 58 over 3. Let's try it. See if it works. I don't know. I haven't tried it myself. I'm just saying it. What's up, Dinan?
It's a negative sign.
Oh, yeah, because the timer ran out. Oh, no?
I had 20 minutes left.
Oh, dang. It's because I put it for 10:16. Don't worry. Just turn in what you have, and we'll that way you can be on this. Don't worry. We'll take care of you. All right. What were we doing again? Oh, yeah. Number 9. Negative what to what? Negative 4 to 1. And then math number ABS 1 minus x squared. X. And check it out. 19.3. Okay. There's rounding. I just told these guys that it told me that. So don't tell me that I didn't lie to you guys. 58 over 3. Do I still have it open? I don't. But they were my witnesses. Did I not? Didn't you guys see that it said? Okay, see? I didn't lie.
In the cafeteria?
It said cafeteria. Mm-hmm. I'll show you after this. The big boss. All right. You guys ready? I am in question 5. Thank you. So we just finished slope fields. And if I go up and down, it does look like y affects it. And if I go left to right, it does look like x affects it. So I think it has to do x and y. So I think it's either this one or this one. Next, I am going to look where I have 0 slopes. And I see this line right here with 0 slopes. Do you guys see that? Those slopes look like 0 to me. And check it out. If I equal this to 0, you get an expression that says y equals x. 0 slopes here. And there it is. That's the answer. And you get really good. The only way to get really good at slope fields, guys, is to to hit them hard. And as you can see, they're not too bad. How do we feel, guys? Do we feel okay? All right. The way to do this one, it's not necessarily a hack. I'm going to rewrite, so I'll put rewrite. Go 3 dy dx plus 4y equals 0. When you do that, I'm going to write the 4y, I'm going to move it to the right. 3 dy dx equals negative 4y. Are we still okay, guys? Okay. So what I'm going to do now, I'm going to move the y's to the left and the x's to the right. Chop, there's no x's. It's just going to be a dx by itself. I'm going to leave the negative 4 there. So I'm just going to divide by y. So I'm going to write it like this. 3 dy over y, I guess you can put the dy over here, equals negative 4 dx. Are we still okay? All right. How do I get rid of the differentials? Integrate. So I have 3 ln, absolute value of y, equals negative 4x plus c. Depending on your professor might tell you get a general equation. and then from the general equation, solve. I like to solve right here. So I see that point as 1, 2, and I'm just going to plug in. So 3 ln of 2, I got rid of the absolute value because 2 is positive, equals negative 4 times 1 plus c. We still okay? So this is a negative 4. I'm going to move it to the left. So I'm going to write 3 ln of 2 plus 4 equals c. That's what I'm going to insert right there. I'm going to go slow. Don't worry, I'm slowing down. 3 ln of y, I guess you keep the absolute value for now, equals negative 4x plus 3 ln of 2 plus 4. So catch up to here. We are done with calculus, guys. All it is now is algebra and arithmetic. So I'm trying to solve for y. Before I can do that, I got to get rid of the what's in front of the ln? The 3. So divide by 3, divide by 3, divide by 3, divide by 3. So here's what I have. ln, absolute value of y, equals negative 4/3 x plus, the 3's cancel out, ln of 2 plus 4/3. Are we still okay? How do I get rid of the ln? E. Whatever you do to one, you do to the other. So put e caret, e caret. So you have absolute value of y. Don't worry, we'll handle the absolute value in a little bit. Equals e to the negative 4/3 x plus ln of 2 plus 4/3. All of it is an exponent. I guess you can put parentheses like that. So all of it's an exponent. All of that is an exponent. I get rid of the absolute value by putting a plus minus in the front. Y equal, I guess I'll do a side note. Side note. Absolute value of x equals plus minus x. That's my side note. Plus minus, and I should have a, okay, tell me if this confuses you guys. 2e to the negative 4/3 x plus 4/3. Is anyone confused by that? Remember law of exponents? This is the same thing as saying e to the negative 4/3 x plus 4/3 times e to the ln of 2. And e to the ln of 2 is just the same thing as 2. All right, which one is it, the positive or the negative? Well, let's see. When I plug in a 1, I better get a 2. So when I plug in a 1 in here, I'm talking about this expression. If I plug in a 1, negative 4/3 plus 4/3, that's 0. E to the 0 is 1, and 1 times 2? 2. So which one is it? The positive one. All right. Last move. Let me put an arrow all the way over here. F of negative 3 equals, I'm just plugging a negative 3 in there. So negative 4/3 times negative 3, the 3's cancel out, it turns into a positive 4. So 2e to the positive 4 plus 4/3. So turn the 4 into a denominator of 3. So 4 times 3 is 12. 12 over 3 plus 4 over 3. 12 plus 4? There it is. Good job, whoever took this quiz. Cool or not cool? Okay. Let me know if we're ready for the next question, guys. Yes, this is pretty tough. I will agree. If f is a linear line, find the integral from 1 to 5 of f prime prime of x dx. Oh, I love this. It's conceptual, guys. I know it's hard because it's Monday and everything. It's conceptual. If f is a linear line, give me any linear line. It doesn't matter which one. Any linear line. What's your favorite one? 2x. All right. If f is 2x, what's f prime? 2. What's f prime prime? 0. So you're integrating 0 from 1 to 5. What do you think you're going to get? It doesn't matter what linear line you put. The second derivative is always going to be 0, guys. Isn't that cool? It doesn't matter. Look, Chop, what if you say f of x is 10,000x? Or I don't know. I don't know how many zeros I put. Look, f prime will be that, and then, well, just a number, and then f prime prime will be 0 again. It doesn't matter. Sorry, guys. Where's Miss Kyle? Her spirit's here because everyone's... Okay, I'll stop. Sorry, Miss Kyle. That was a joke. LOL. Okay. Find the volume of the solid generated by revolving the region x equals y squared and 2/3 x equals y plus 2/3. Man, that one's a hard one. Find the volume of the solid generated. Okay. This is the same thing as y equals plus minus square root of x. So that looks like this. And this one is y equals 2/3 x minus 2/3. So that one looks like point that. And I'm revolving about the y-axis. So it's this region right here. Do you guys see that? Oh. I can't draw, guys. I got a D in art. Okay, you know what? I'm done with that. When I rotate it, I'm just looking at this region, and I know it's not perfect. Well, look, now it is kind of. It's gonna look something like. And
How are you supposed to do that?
well, I'm just rotating it. See, I'm not perfect. I got a D in art, and I still can't draw perfect. But yeah, but notice, like I just did. Those are basic shapes: a quadratic and a linear line. And then when you rotate it, you can see that. And you get really good at this, guys, by practicing. Hopefully, by now you've done 100 volume problems, and you're good. No, you have, because the UH quizzes, the Delta Math. If you've done all that, honestly, you pretty good. Like, you got the experience already. So now you just gotta tackle them. All right, here we go. That's a dy. Notice that washer is a dy. Well, first notice it's a washer. Are we okay with that? And then notice this is a horizontal cross section, so that's a dy. And I'm going to add them all up. So I'm going to integrate with respect to y. I need this value and this value. Job. I don't know how to get that. Yeah, you can plug it into the calculator. You know what? Let's do that. I'm going to plug this square root of x, y1 and y2. I'm going to go like this, guys. y1, I'm plugging square root of x. y2, I'm plugging negative square root of x. And y3, I'm plugging 2/3 x minus 2/3. So there it is. y1, square root of x. y2, negative square root of x. And I already forgot. What was y3? 2/3 x minus 2/3. And really, I just care about the one in quadrant 1. So you just care about these right here in quadrant 1 and quadrant 4. So I'm going to tell my calculator. One of them is obvious. Well, let's find the lower one. Second, calculate number 5. Enter, and then which one am I doing? That one down there? Enter. Did you guys get error? No sign change. Oh, what did I put? 0. Second, calculate. No, I put intersect 5. Let's see. What curve am I at? Y1? No, I want Y2. No wonder. There it is. Y2, the red one. And then the black one. Enter. There we go. Yes. So negative 0.5. Is that what you guys got? Okay. So remember that. Write that down somewhere. Second, calculate number 5. And then I want the blue one and not the red one, but the black one. There we go. Bam. And there's the other one, 2. All right. Here we go. Pi on the outside. Integral negative 0.5. That's the lower limit. And remember, these are y's. All the way to 2. And my big R from the y-axis all the way to that linear line. Well, all I got to do, remember, I got to have it in terms of x equals. You got to have a y in there. So just multiply that by 3 halves. X equals 3/2y plus 1. Now, I make mistakes all the time, so make sure that that's correct. Parenthesis, 3/2y plus 1, close, put a square on it, minus, and then that one already says y squared. Y squared squared. And bam, bam, dy. Don't put the pi in there, just put that. So So here we go. I'm going to take my calculator. I don't have that in there, guys. So I don't have that embedded into y. So I'm just going to type in an x instead of a y. So I'm going to go math, second quit, math 9, negative 0.5. I already forgot. Was it 2? And then open a parenthesis. And I'm going to write 3/2 y plus 1. So 3 over 2. Instead of y, I'm going to put an x plus 1. Close it, put a square, minus parenthesis x squared, close it, put a square again, and then let's put an x here. And there it is. Turn that into a fraction. 125 pi over 16. 125 pi over 16. Good job. Ooh, that was hard, guys. That was tough, but we can do it. You guys ready for this one? The base of a solid of the region bounded by y equals 2 e to the negative 3x, and the x-axis is the y-axis, and the line x equals 2. Each cross section perpendicular to the x-axis is a square. Okay, so you got to know how this looks. That looks like y equals e to the negative x. So you don't have to be perfect, guys. The x-axis, so this guy, and the y-axis, so this guy, and x equals 2. So here's x equals 2. So this is a region, and then each cross-section perpendicular to the x-axis is a square. Okay, here it is. Here's my square. Let me see if I can draw it perfect. It's coming out of the board. Does that look 3D? That's a dx. Volume equals integral 0 to 2. And then the side of this square is the top of this curve minus the bottom of that curve. So it's just going to be 2e to the negative 3x, close it, put a square on it, because area of a square is side squared, dx. Yeah, this time they're probably going to want me to do this by hand, which is fine. When you have an exponent raised to an exponent, volume equals integral 0 to 4. 2 squared is 4. And now that's going to be e to the negative 6x. Where'd I get what? Oh, yeah, 0 to 2. 0 to 2. Sorry, thank you. I would have been wrong. 0 to 2. I was getting ahead of myself. 2 squared is 4. I think everything else is correct, right? Okay. Antiderivative of an exponent is itself. So 4e to the negative 6x. Now, in chain rule, when we take the derivative, you would have multiplied it by negative 6. But I'm not doing derivative. I'm doing antiderivative. So we're going to divide by negative 6. This is evaluated from 0 to 2. The 0, it does play, guys. The 0 does play. I'm going to move the negatives there, and I'm going to reduce this. 4, 6 reduces to 2/3. So here it is. Negative 2/3. I'll put it right here. Negative 2/3. Upper minus lower. E to the negative 12. Negative 6 times 2. Minus, what's e to the 0? 1. There it is. So let's find that answer first. They don't have it like that. Distribute that. That's if you have a polynomial. This is an exponential. Negative times the negative is a positive, so 2/3 minus 2/3 e to the negative 12. Is that in there? E. Yeah, these are going to take a while, guys. We got to make sure that. All right. Here we go with this one, guys. Integral 1 minus 4y over the square root of 4y squared minus 2y plus 6 dy. And at first glance, you're like, Chav, I don't know how to do this. Observe that if you take the derivative of the inside, you would get 8y minus 2. And look, notice if you factor out, you'll get that answer. Do you guys see that? So I'm going to write u equals 4y squared minus 2y plus 6. And I'm just going to write du. So du equals 4 times 2, 8y minus 2, and then put a parenthesis like this, dy. What am I going to factor out to make it look like that 1 minus 4y? So I'm going to factor out a 2, so here it is. And then I'm going to have 4y. Actually, I'm going to have to factor out a negative 2. So put a negative 2 like that, and then you'll have it like this. 1 minus 4y, close it, dy. So here we go. Here's what I need. So everything you see in different color is stuff that I'm adding. I'm going to put a -2 right here. So that means I put a -1/2 on the outside. And that's it. We're ready. So -1/2. And I'll slow down, guys. Integral 1 over square root of u du. I'm bringing this up. This is not an ln. I'm bringing that up. I haven't done the antiderivative yet. U to the -1/2 du. And now I do what you told me, Houston. Add 1, divide by that number. So -1/2 times u to the 1/2 divided by 1/2, which is the same thing as multiplying by 2. So there it is. Negative times a positive is a negative. So negative square root. I'm plugging back what u is because we don't have any limits here. 4y squared minus 2y plus 6 plus c. You got it right. Good job. All right, let's see. Find a specific solution for this expression. Okay, so we're going to group the x's with the x's and the y's with the y's. So move this, all of this is all a product, move it to the right. By the way, these are harder, in my opinion, these are harder than the AP exam. Y dy dx equals, parentheses, 4 plus y, close it, x squared. Okay. Y's with the y's, x's with the x's. Divide by 4 plus y, multiply by dx. Bless you squared. Y over 4 plus y equals x squared dx. Oh yeah, dy. There's one of those special ones. Yeah, okay. This is a BC problem. Do you guys think we can handle it or no? Should we exempt it? Okay. This one exempt. Put in there BC problem. We'll let your calculus professor at the university take care of it. Or if you decide to, well, Dean, you'll see this next semester, so it's not a big deal for you. I think you guys can do it. It's gonna have an ln in there. It's probably gonna be okay. Well, let's not take a guess. Skip number 11 whenever you get to it. Give a formula for f of x given f is continuous and okay. You see this right here? Notice the upper limit is x and the lower limit's a constant. So just take a derivative. Take der. So when you take the derivative, -4x cubed plus 2x equals, the derivative of this integral is going to be the same. It's going to be f of x over x plus 2. Notice all of these answers don't have f of x over x plus 2, so multiply by x plus 2. Whatever you do to one side, you do to the other. Make sure to put parentheses like this, guys. So you're going to have to FOIL. Lame, right? All right, let's see. X times -4x cubed, -4x to the 4th. X times 2x plus 2x squared. I think I'm done with that one. 2 times -4x cubed minus 8x cubed. 2 times positive 2x plus 4x equals f of x. Let's put it in order, guys. Highest degree to lowest degree. Let's see. Is this the highest degree? Yeah. So, and then this one. So, -4x to the 4th minus 8x cubed plus 2x squared plus 4x. All that equals f of x. Do we have that answer anywhere? Which one is it? B. You got it right. Good job. For what value of k is the following equation true? Okay. 3x. Is that an odd or an even problem? Odd or an even function? Odd. 3x looks like this. All linear lines that go through the origin are going to, well, except for y equals 0, right? But, well, if it has an x, all y equals kx or whatever, some constant x are going to look like that. So here's -2. So where is this equal to 0? Well, -2 and 2, those cancel out. So k equals 2. And there's one more. So you were so close, miss. What's that one more? At -2. What if you don't move? If you don't move, it's going to be 0 also. So negative 2 and 2. Is this helping, guys? Or okay. For an even function, all right, so underline the word even. Integral from negative 3 to 0 of f(x) dx equals 3. Determine the average value of f. Okay, that's not a bad deal. So here, if it's an even function, so let me go ahead and I'm going to rewrite this, guys. I'm going to go integral from negative 3 to 0 of f of x dx equals negative 3. Is everyone okay with that? Okay, if I have an even function, I'm just making something up. So that means negative 3, so that means I'm below the x-axis. Well, it doesn't. Okay, let me make sure that we understand. You can have some above the x-axis, but I don't know how it looks. So I'm just making life easier, and I'm just going to say this is this. Is that okay with you guys? Okay. If it's even, that means it's symmetric on the y-axis, guys. So it's going to look like this. Again, I can't draw for crap. See? This is negative 3. This is negative 3. It wants average value 1 over b minus a, integral a to b of f of x dx. So here we go. 1 over 3 minus a negative 3. That's going to be 1, no, 1 6, right? 3 minus a negative 3. And then, oh, yeah, you're right. Sorry, I thought you were. And then integral from negative 3 to 3, well, I just add these up. What's that? Negative 6. So 1 6 times negative 6, what's that? Negative 1. That's the average value. Letter E on the next page. Yay, we're almost done, guys. We got 10 more. See, you need a calculator for this one. Yeah, but you're going to use a calculator for the rest. What is the approximate instantaneous rate of change of this? So all we got to do is take a derivative. Instantaneous rate of change. That's what it means. F prime. F prime of x equals, type it in, cosine of 6t times, what's the root of a 6t? 6. Or respect to, 6x is, okay, 6. The root of a 6t respect to t is just 6. So I'm taking the derivative, there it is. So f prime of pi over 9 is 6 cosine 6 times pi over 9. Type it in the calculator. Take your calculator. Yes, you can use the 6 pi over 9 if you want. Make sure you're in radian mode. Some of the calculators have been used by the pre-calc kids, so they're in degree mode. 6 cosine, and I already forgot. 2 pi over 3. 2 pi over 3. Make sure you're in radian mode. And negative 3. We're okay? Use the table below and a right endpoint for n equals 5. Okay, if n equals 5, 2 minus 0 divided by 5. So 0.4. So here it is. Here's my first rectangle. Bless you. Second rectangle. Third rectangle. Fourth rectangle. Fifth rectangle. Do you guys see them? How do I find every rectangle? Width times height? Or yeah, you can say length times width. All of these are 0.4. All of these. So can we just factor out the 0.4? So here it is. 0.4 factored out. Open parenthesis. Right, we're doing RRAM. So the first one's going to be 4 plus the next one's going to be 4.1. The next one's going to be 4. 4.7. One more. 4.1. Type that in the calculator. So here we go. 0.4. Parenthesis, hook me up. 4 plus 4.1 plus 4. 4.7 plus 4.1. I got 8.36. 8.36. Oh, they gave you guys a real hard one here. The AP exam will not have one like this. At least I haven't seen a free response like this one. I've seen some similar, but not at this level. Let R be the region in the first quadrant bounded by the graph 9 minus x squared. Okay, so here it is. 9 minus x squared. -3, 3. And the coordinate axis. Determine the value of k such that y equals kx squared. Separates R into two regions of equal area. Okay, hold on. I got to think about this. Let's think about this, guys. Let R be the region in the first quadrant. Okay, first quadrant. So I'm going to delete all this stuff here. Delete. I don't care about it. Determine the value of k such that y equals kx squared separates R into two regions of equal area. Okay. Find the area under the curve between 0 and 3 first of 9 minus x squared, and I'm going to divide it by 2 because equal area, right? So I'm going to go math 9, and I already forgot, 0 to 3, and it was 9 minus x squared. 9 minus x squared. And I got 18. So that means all this is 18. All that in blue is 18. So if I divide this by 2, I want this area right here. Let's see, which one am I going to do? I'm going to do burnt orange. I want this area in burnt orange to be 9. Upper minus lower. Okay, here we go. I do not know what this value is. I'm going to put a for now. Integral 0 to a. I don't know what that number is, guys. And I'm going to do upper minus lower. So I'm going to go 9 minus x squared minus kx squared. And that has to equal 9. So let's do that. Oh, yeah, I got to put the dx. Or else the professor will frown. Okay. I know that coordinate, let's see, this parabola there is y equals kx squared. So I know that this coordinate is just some x, comma, and the y value is some kx squared. So how's that going to help me? Oh, okay. 9 minus x squared has to equal kx squared. I'm going to solve for x. It's going to be, this is a hard one, guys. This is a real hard one. I'm going to move this x squared to the right. 9 equals kx squared plus x squared. Let's see. I said we're going to solve for x. So I'm going to have to factor out an x squared. 9 equals x squared parenthesis k plus 1. X squared equals 9 over k plus 1, and then square root. X equals 3 over square root of k plus 1. Man, that's a hard one. No, because we're in quadrant 1. Hold on, guys. So I have that. This value is 3 over square root of k plus 1. They're going to force me to do it by hand. Okay, that's fine. Yeah, they're forcing you to do it by hand, guys. So you guys ready? I'm just going to do the antiderivative of this. And then I'm going to plug in my square root of k equal to 9. I'm going to use my calculator. So antiderivative of 9 is 9x. Antiderivative of x squared is antiderivative of kx squared. Kx 3 over 3. This is evaluated from 0 to 3 over square root of k plus 1. Are we still okay? Okay, man, this is so hard. Equal this expression. What area do I want? 9. And then just use the calculator to solve. So I'm going to plug in this expression. So I'm going to have 9 parenthesis 3 over square root of k plus 1, close it, minus parenthesis 3 over square root of k plus 1, close it, put a third power, minus k parenthesis, remember this is all over 3, k parenthesis 3 over square root of k plus 1, close that, to the third power over 3. What's up? Over 3. Okay. I think I have it right. You're not going to do anything. Okay. Let me catch up. Let me make sure that you guys understand it. I know. This one's hard. You won't get anyone anytime. This is why if you kill these guys, you'll kill. Yeah, well, we're going to start making huge games, hopefully. Look what I'm just doing, guys. I just plugged in my upper limit. Here's my expression, and all that equals 9. I'm going to tell my calculator to solve that. I'm just going to, instead of a k in the calculator, I'm going to type in x. So we just got to be very careful. Go to your y equals and type in that expression very carefully. What was my first one? 9 times, so here it is, 9, open parenthesis, alpha y equals, enter. And what did I have? 3 square root of x plus 1. I'm going to close it. Was there any powers on this one? No. And then was it minus?
Yes.
Minus, and then I'm going to put a fraction feature because there's a 3 in the bottom already, and then I'm going to use it again in a little bit. There's my 3 in the bottom. And let's see what I have on the top. Okay, parenthesis. So let's do it again. Alpha y equals, enter. And I have a 3 there. And square root of k plus 1. With it to the power of 3 or no? Okay, so let me put that in parentheses. Parenthesis here. And parenthesis here. And power 3, right? Okay, there it is. And minus again. And then I have alpha y equals, there's a 3 in the bottom again, right? And on the top, let's see, this time I think I have x times. X times. So I'm going to write x, open parenthesis again, alpha y equals, enter. And then put 3 over the square root of x plus 1. Let's see. Close this to what power? 3. Did I do everything correctly? All right. Make y2. Yeah, I would like to see a university student do this question. See if they can do it. Make y2 equal to 9. Click on window. You're only looking between 0 and what? And 3. 0 to 3. Y min 0. It only goes as high as 9. So actually, you don't even have to put 9, but I'm going to put y max 9. Oh, actually, yeah, not 18. We made it equal to 9 here. So I'm going to go to 10. Sorry. Okay, let me make sure everything's correct. Why does that say 9 there in front of y1? There was a 9? Oh, okay. Graph. All right, let's see. There it is, way out there. Let me see if it can get it. Second, calculate 5. Enter. Oh, it's at 3. Is there a 3 in there? Man, that's dumb. Oh, look, you got it right. Man, they made us go all the way to. So right at 3. That one was brutal. Yeah. Okay. Now that one was hard, guys. If you have a professor, a friend that's a professor, give it to them and see how fast they can solve it, just for kicks. All right, this one's gonna be simple. You're gonna always do this for this one. This is like velocity, and this is like position. Suppose that f of 2 equals 5. Find f of 6. Okay, here it is. It's gonna look like this forever. F of 6 is equal to f of 2 plus integral from what to what? 2 to, no, not 5, 2 to 6 of f prime of x. It's going to look like that forever, guys. There it is. F of 2, 5 plus integral 2 to 6 of this guy. 3 over 4 plus cosine 2x, close it, all that squared dx. If you feel that you're going to make a mistake with that cosine 2x, all those parentheses, put that in y1. Go y1, and I'm just going to type in just the trig part. 4 plus cosine 2x. 4 plus cosine 2x. So there it is, 4 plus cosine 2x. And I'm going to go clear this. 5 plus math 9 from what to what? I already forgot. 2 to 6. And let's see, what do I have in the numerator? 3. So alpha y equals enter 3 in the top. And in the bottom, I have that stored as y1. So I'm going to put y1 squared. Alpha trace y1. Put a square on it. I don't have to worry about it because I typed that in already. And I push enter. 5.805. Is that what you guys got? You got it right. Good job. I'm surprised they didn't put 3 digits in there. Number 19, guys, nothing by hand. I can already see it's an exponential law of cooling. Maybe you've heard of Newton's law of cooling. That's the same thing as this when you do it in physics. A solid ball is made of composite material. I know, we're almost done. We just got 5 more. A solid ball is made of composite material. The temperature T in degrees Celsius times T hours of the center of the ball satisfies the equation. So this is T prime. If T of 0 is 30, then T of 50, here it is. T of 50 equals T of 0 plus integral from 0 all the way to 50 of T prime. So you're going to write 30 plus integral 1/3 e to the negative t over 100 dt. And let's see what that is. So I'm going to take my calculator. 30 plus, make sure you practice, guys. Math 9 from 0 all the way to what? 50. And let's see, second e to the power. Oh, I didn't put a 1/3 in front. So 1/3. 1/3 second e to the power negative t over 100. Yeah, negative x over 100. Since it's just 1, I can do that right there. X. And we get 43.1156. 43.12. Nothing by hand, all calculator. Find the area of the region bounded by the graph and the x-axis between 0 and 7. I see that this is going up and down. Do you have to do anything by hand? No. Integral 0 to 7. Be careful. Remember the hack that we did earlier? This is going above the x-axis and below the x-axis, but I don't want to do a whole bunch of integrals. How do I just do it with one? I put a what? Absolute value of sine x squared over 7 plus x over 9 dx. There it is. Take the calculator, absolute value. So I'm going to go math 9. See, all these last ones just with the calculator. 0 to 7. Let's see. Math number ABS. And then what was the expression? Sine of what? X squared over 7. And then get out of there. Plus what? Plus x over 9. Plus x over 9. All right. If we did everything correctly, 4.5088. 4.5088. 4.51. Cool. Don't worry, guys. 4 left. And hopefully the rest they're all look to be. In a bacteria growing experiment, biology observed that the number of bacteria in a certain culture triples every 2 hours. Okay. Triples, why not? Times 3 over t over 2. There it is. If I plug in a 2 in there, I get 3, why not? So there is my formula. After 8 hours, it is estimated there are 1 million bacteria in the culture. What is the doubling? You don't need that. You don't need all this. That's just extra information. Who cares? What is the doubling time for the bacteria of the population? Okay, doubling time. 2 why not equals why not times 3t over 2. Semicolon, solve for t. There it is, guys. You're just solving for t. Why nots cancel out? Bam, bam. How do I bring that t over 2 down? ln of 2 equals t over 2 ln of 3. Multiply this by 2. So I'm going to have T ln of 3 equals 2 ln of 2, and then divide by ln of 3. And there it is. It's 2 ln of 2 divided by ln of 3. So 2 ln of 2 divided by ln of 3. And 1.2618. That's the doubling time. There you go. You got it right. Good job. You could also solve for K if you wanted to. Okay, we got 3 left, and then we'll call it a day, guys. The region above y equals 6x and below y equals 7 sine x. The region above y equals 6 is rotated around the x-axis. Give the volume of the solid generator. Okay, here it is. Don't worry, we're almost done. So it looks something like, and below. Okay, so it looks something like this. It looks something like that. And I'm rotating it about the what? X-axis. So here it is. It kind of looks like Pac-Man a little bit. What shape is this? Okay, guys, you think I'm kidding, but I'm 100% serious. This is holy water. I'm going to buy some washers, and I'm going to give them to you guys, and I'm going to spray holy water in them.
What?
Yeah, I'm being serious.
That's holy water?
That's holy water. I'm going to go to Walmart tonight and buy some washers.
Why?
Because the year that we got 100% qualifying, we had holy washers, and I don't know if it works, guys, but I used to. You guys are gonna think I'm weird, or maybe you guys already think I'm weird. Okay, here's what I used to do. I'm not even kidding. I used to go to church right before the AP exam, and when the preacher guys, if it was a church that said like, "Do anyone need any prayers?" I would go up, and so if they asked like, "Why do you want me to pray?" I'd be like, "Oh, my kids have an AP test tomorrow." He would put his hand on me, my forehead. It was. I don't know what type of church that is. Oh, some random one, like any Baptist church. Those are probably the Baptist churches that do that. All right, here we go. Ready? I'm going to equal 6x equal to 7 sine x, and I'm going to find what that x value is, and I'm going to store it in the calculator. It's going to happen very fast, guys, because the 6x, the 7 sine x are going to go quick. So I'm going to go 6x and 7 sine x. 7 sine x. And window, that's fine. Graph. I need that one right there. Second, calculate number 5. Enter, enter, enter. 0.946826. Store that. I'm going to store it to A. So I didn't even push X. Practice storing this, guys. There it is. And let me put that number in here. X equals 0.9468. I know you guys are tired. All right, 0.9468. Here we go. I'm going to store that to A. Pi on the outside, integral 0 to A, big R, distance from the x-axis to the sinusoid, parenthesis, 7 sine x, close it, squared, minus little r, distance from the x-axis to the linear line, or linear line minus x-axis. So minus 6x, close it, squared, and then dx. There it is. Type it into the calculator, guys. Put pi in the front. Pi. Math 9. 0 to A. And I already forgot where I had which one. 7 sine x is on y2. Okay. So y2 squared. Alpha trace y2 squared minus alpha trace y1 squared. If you get a negative number, guys, something's wrong. 4.3807. I'm surprised it's so off. 4.36. There's not going to be another one that's close to it. I guess maybe they're rounding or something. Okay, cool or not cool? All right, 2 left. 3 left. What's up? Oh, check your mode. It might be in degree. If the pre-calc kids were using it. No. Did you store it like that into A? Check your A, that's 0.9468. Okay. Suppose that c is greater than 0 and that the average value on 0 to c is 1/3. Find the value of c. This is kind of calculator, guys. Let's see. The average value. Okay. Find the value of c. So here we go. Ready? I'm going to go 1 over c minus 0 integral from 0 to c of e to the negative 2x dx. All this equals 1/3. So here it is. 1 over c times antiderivative of e to the 2x or negative 2x is itself e to the negative 2x. If it were chain rule, if I were doing derivative, I would multiply by negative 2. But I'm not doing derivative. I'm doing antiderivative. So instead of multiply by negative 2, I'm going to divide by negative 2. And all that, okay. Line from 0 to c, bracket right here, really. And all that equals 1/3. Are we still okay? Okay, the 0 does affect it. So here it is, guys. I'm going to factor out that negative 2. So I'm going to write it over here. So here's what I see. Negative 1 over 2c, bracket. E, if I plug in a c, that's going to be e to the negative 2c minus e to the 0 is 1. And all that equals how much? I would stop right there. Don't even try it. Type that in the calculator. Type this in y1. Type that in y2. And notice all the values are small. So here we go. The c is the x, guys. So I'm gonna go alpha trace, enter 1 over, with a negative first. Negative 1 over, so the c is gonna be an x. Yeah, I put a delete. And then I'm gonna put parenthesis. And I'm gonna type in e to the negative 2x. Second, e to the negative 2x minus 1. Was it minus 1? Okay, and then on y2, I'm going to type in 1/3. Push window. Notice all the answers, guys, are small. Those are x values or c values. So I'm going to go from 0 to 3. There it is, 0 to 3. And then I just care about 1/3. So y max, I'm going to make it 0.5. And there it is. Push graph. And find that intersection. Second, calculate number 5. Enter, enter, enter. 1.4107. Is there a 1.41? Two left. We're done. Oh, yes. All these have been all calculated. If the velocity of a particle moving horizontally is given by that equation, find the total distance traveled between 0 and pi over 2. How do I find total distance? Absolute value. Good job. Integral from 0 to pi over 2, absolute value of 3 sine x plus 3 cosine x. Close it, dx. You do not have to do anything by hand. Math 9. I already forgot the integral. From 0 to what? Pi over 2. And ABS, so math number ABS. And then type in, there you go, 3 sine x plus 3 cosine x. I got a perfect 6. Is that what you guys got? Last one. I know some of you are thinking delete letter A, but it could be letter A if you have to do something called partial fraction decomposition. X plus 5 and x minus 31 are not factors of that denominator. I'll let your Cal 2 professor talk to you about that. Delete letter A. Which one else is the worst one? D is the worst one. And maybe even letter E. Yeah, letter E also. Letter E is doing chain rule, is taking this up, -1, and then taking a derivative like that, but you can't, that's not how it works. It's an arctan. Which one is it? Well, you got it correct, but let's figure it out. Complete the square. Because remember, the derivative of arctan is 1 over x squared plus 1. So here it is. So I'm going to complete the square. So I'm just doing the complete the square with the x squared plus 10x plus 31. So take the first two. Take that 10. What's 10 divided by 2? 5. And 5 squared? So write x squared plus 10x plus 25 plus 31 minus 25. That minus 25 is for balance. And everything I'm writing in blue for balance. So now here's what I have. I have x plus 5, close it squared, plus, and the difference between 25 and 31 is 6. So that is the same as that. So here's what I'm going to do. So I'm going to go integral 1 over, and I'm going to write this, it doesn't matter which one you write first. I'm going to write the 6 first. 6 plus x plus 5, close it squared, dx. All right, I need that 6 to be a 1. Divide by 6, divide by 6, divide by 6. We're still okay? All right, so I'm going to rewrite it. Integral, here's my 1/6 so far at the moment. 1 plus parenthesis, x plus 5 over square root of 6, close it squared, dx. Don't worry, guys. Here's the last one. We're almost done. I'm going to do u sub. I need that to be...
Oh, never mind.
I'm going to go u equals x plus 5 over square root of 6. du equals 1 over square root of 6 dx. We're still okay? So check it out. Here's what I'm going to do. You see that 1/6? I'm going to turn that into 1 over square root of 6 and then put 1 over square root of 6 on the outside. And there it is. That's still 1/6. Yeah, that's cool, right? You guys don't think that's cool? All right. Are you not entertained? Oh, okay. You're fine, miss. You can say you're not entertained. You have free will. Oh, stop. All right, here we go. I have 1 over 1 plus u squared du. When I substitute everything, see? Equals, what's antiderivative of 1 over 1 plus u squared? Arctan. And because this was not about u, because it has no limits, we go back to our x on this one. 1 over square root of 6 arctan of... what was my x? Oh, there it is. X plus 5 over square root of 6. And there it is, letter C. Good job, you got that one right. That was tough, guys, but if you can do that, I think we'll be in good shape. Well, you get faster. The first time, we never do. But the second and third, look, we talked about it, and we went over it, and we even had some pauses, and we still finished. Oh, it's 2 hours on this one.
Oh, okay, perfect.
Yeah.